Okay, Math 11, Pre-Calculus Lesson 1. I am going to split this up into two parts. This is going to be part 1. Radicals. Entire radicals, mixed radicals. First, a little bit of review. That's what this says. Recall square roots, cube roots, other roots, square root. We like to do this. Okay, we don't really like doing that. What's the reason? Because that's a perfect square. You know, well, the definition of a perfect square is the product of two equal factors. You guys know 4 times 4 is 16. So 16, by definition, then is a perfect square. Anytime you take the square root of a non-perfect square, you're always going to get an irrational number. Okay? That is a bunch of decimals that go on forever and ever and ever. Now, -4 times -4 is some factor multiplied by itself, which gives us this same number 16. So we could say the square root of 16 is plus or minus 4. Okay, they got a note in the book here. If we're just asking you for the square root of 16, we're just going to say that it's 4 only. But as long as we're aware, -4 times -4 is 16. Okay, and then cubed roots, which we introduced as part of the curriculum in grade 9, I don't know, a couple years ago. All right, because some number times itself is equal to 16, 16 is a perfect square. Well, what happens if we have some number multiplied by itself not once but twice? For example, 2 times 2 is 4 times 2 is 8. Then we can say the cubed root of 8 is 2. Okay? The fourth root of 16 is also 2, because there is some number multiplied by itself 4 times to give you 16. That number happens to be 2. Then I can say the fourth root of 16 is 2. And we can have the fifth root, the sixth root, the 19th root, so on and so on and so on. Okay? When you see a bunch of zeros, think 10. Okay? I know we all know this. Okay, you learn that pretty quickly. Now we're talking cubed roots, fourth roots. Okay, just think to yourself, when you see a whole bunch of zeros, how many times can you multiply 10 by itself, and then kind of work backwards from that to determine whether it's cubed root, fourth root, sixth root, whatever. Okay? So cubed root of 1,000 is 10 because 10 times 10 times 10 is 1,000. Some negatives. The cubed root of -27 is -3. Okay? That's what this says. So remember, a negative times a negative times a negative is a negative, right? Negative times a negative is positive. Positive times a negative is a negative. Okay, so cubed roots and fifth roots and seventh roots and any odd root, we can do this. We can have a negative under the sign, but it's going to ask us in a few minutes whether if it's a positive, we don't know the number yet, it's coming up, but let's say it now, that's an index. What if I have a positive index of a negative something? Okay, we're going to see in a sec what happens there. So, fourth root of 16, I just did it up here, that's 2. But we can also go -2 times itself 4 times to also give us 16. And negative, like I just alluded to, if it's odd, then we're allowed to do that in public school. Okay, there is some number multiplied by itself 5 times to give us -32, and that number happens to be -2. What I'm trying to say is, well, let's just get to it. Right there, that guy. Okay, so square root. This is a 2. Okay, if it's not given, if there's nothing there, it's understood that it's a 2. Is there a number multiplied by itself to ever give us a negative? And the answer is no. All right? If I have a positive times a positive, of course it's positive. If I have a negative times a negative, of course it's positive. I can never get a negative by multiplying something by itself. So we say in public school, we can't do that. But then if you take math at university, then we tell you actually you can. Okay? Your calculator. Let's see what that says. If I try to take the square root of negative 64, what does it say? It says error, non-real answer. There actually is an answer, but it's not a real one. It's an imaginary one. So, as far as we're concerned, if we're in public school, we're just going to say you can't do it, and that's fine. Okay? Now, cubed root, fifth root, seventh root, any odd root, yes, we can do that in public school. What times itself 3 times is negative 64? Negative 4 times negative 4 is positive 16, times a negative is negative, times 4 is 64. Okay? Now, don't use a calculator. It says not to. You're doing yourself a disservice if you do. Because on your test that I'm giving you, you're not going to be able to use a calculator. Because some of these things are cheater calculators. They're pretty smart. Okay, this one's pretty tricky for our fourth question here. But we remember this. Okay, if it's just positive, what number do I multiply by itself 5 times to give me 32? It's 2. So just look at the denominator here. Okay, think cooking. All right, if I got a half a cup of flour and I need to cut this recipe in half, then how much flour do I need? What's half of a half? A quarter. Okay, and now if I need to just make it for myself and I take another half of that, excuse me, I get an eighth. You see a pattern here? What if I take another half? What if I take another half? Okay, the number multiplied by itself 5 times to give us 1/32 is a half. But there's actually another way of thinking about doing this, but that's not until the next page when I show you some rules, okay? Can I ever multiply something by itself an even number of times and have it be a negative? No. Okay, so any even index in public school, we're going to say you can't do. So 8th root of a negative, nope. 12th, nope, can't do. Okay, this one looks a little different. Why? Because there's a number out front here that isn't a 1. This one happens to have a 10 here. So in English, all we say is this is 10 times the cubed root of 125. Just like back in grade, I don't know, 7, did you first start seeing this stuff with the letters? That says 2 times x, right? The operation between the 2 and the x is a multiply. Same thing here. So that's 10 times, what number do I multiply by itself 3 times to give me 125? 5 times 5 times 5 is 125. So this says 10 times 5, which is 50. Okay, on your calculator, there will be some questions that will say, you need to know how to use it. You need to know how to put this in. You need to know how to do that. You need to know how to do that. But like I said, on your test, we're not going to be able to use it, okay? Some of you guys are going to cheat. So, let me just do the middle one. Where do I find a 7th root? You know where the square root button is. Now, everybody's calculator works differently, okay? So, you just need to know on your calculator where that is, how to get it, and how to use it, and get the mark. On this, I hit a math button. And there it brings up a cubed root by hitting number 4, or going down to number 4 and hitting enter. And an anything root. That is number 5. So for this, I gotta want to put in, it says it down below, but let's call it by its proper name, the index 7, then hit the math button, then hit number 5, Now I'm going to take the 7th root of what? Of negative, which I can do because it's an odd index, 16,384. So what times itself 7 times is negative 16,384? I have no idea. Negative 4. All right. This guy I'm going to do 2 different ways. We don't know the little trick yet, okay? But on your calculator, if you just go the cubed root of 125 divided by 216, that's what your calculator is going to think you are wanting to enter, and that is completely different than this, okay? These are not the same thing. So, if your calculator doesn't automatically give you a bracket, you have to bracket this. And if you do, now it's going to take the square root of the whole thing, not just the 125 part. Okay? Garbage in, garbage out. But this is going to give me a decimal. And what's the question say? Exact value. That's not exact. That's 0.83 repeat. So hold that thought. I'm going to come back to that question. Okay? So know how to use a calculator. Evaluate to the nearest hundredth. This is the weird one. Again, it's just 2 divided by 5 times. Do that part first if you don't have a really good calculator. And if you do, it'll do BEDMAS for you. Okay? But again, this is going to be an ugly decimal. All I'm saying is you need to know how to use it. Okay, so here's the biology. This little number thing in the square rooty thing is called the index. This is a radical sign. Okay? The number we're taking the square rooty of is the radicand. And if we're just referring to the whole thing, it's a radical. Whether it's cubed root, 4th root, 8th root, whatever. Okay? So it's just nice to know what this stuff is kind of called when you're referring to it, instead of just so you don't have to say thingy. And oh, like I said, if it's nothing there, then it's a 2, right? It's a square root. There's 2 factors here. It's understood. So, combining radicals. Let's look at this. Verify. Square root of 9 is 3, okay, times square root of 4 is 2, so that's 6. Is this 6? The square root of 9 times 4, which is 36, is that equal to 6? Yes. So this is equal to that. When we're dividing, let's have a look. Root 9 over root 4 is 3 over 2, which as a decimal is 1.5. Is that the same as that? Square root of, how many times does 4 go into 9? Here I'm going to cheat and use my calculator. Whoop, that's not what I want. Square root of 9/4 is 1.5. Is that the same as this? Yes. So this is true. This is equal to that. What we're trying to do here is prove a rule. We're going to give you. The product, or quotient, of the roots of 2 numbers is equal to the root of the product or quotient of the 2 numbers. Do you like words? Does that make sense to you? Here. This is what we're trying to say. Okay? In general, I don't care what A is, 9, some other number, I don't care what B is. As long as they have the same index, which these do, then I'm going to word this as, join them together under the same radical and multiply them together. Okay? And if you're dividing, you can join them together under the same radical and divide them. We're going to use this to solve some problems because we don't all have cheater calculators, and this is knowledge. So you notice the difference here? I don't want to emphasize this too much So don't look here if you've got like a photographic memory, because then you'll try to do this on the test. But if it's a plus or a minus and not a multiply and divide, you can't do it. Okay? You can't. I could prove that in my calculator, but just trust me. So, true or false? Can I do this? Can I go root 3 times 5 is root 15? Yes, that looks exactly like this, where A is 3 and B is 5. I can join these together, okay? I just proved up above that I can do this. It'll work. Same thing. Can I join these together? Yes, because they're both square root, so I can join them under one root, and 30 over 10 is the same as the square root of 3 over 1, which is the same as square root of 3. So that's true. That's true. How about this guy? Can I plus or minus them, add or subtract? No, I can't. False. And the question you're thinking is, am I going to try to trick you? Am I going to put one on there and say, do? I don't know. Depends on my mood. I'm just going to skip over this for now. Okay? I'm going to prove it in a different question. Now, this is the real substance here. This is the name of this lesson, okay? Entire and mixed radicals. What's the difference between that, this, and this compared to, whoop, wrong pen, compared to this one, and this one? These are all mixed radicals, and these are entire radicals. What's the difference? There's a number in front of this. There's a number in front of that. And there is a number in front of that. You can kind of think of it like a coefficient, but this isn't a variable, so that's not really true. But the point is, the only number in front of an entire radical is a number 1. Okay? Nothing else. If there's another number there, it's mixed. So that's the difference. Now, like I said, here's what we're really going to do. Convert an entire to a mixed radical. We call this simplifying. Okay? So this, root 72, square root of 72, is an entire radical. I want to make it a mixed radical. And how are we going to do this? We are going to look for perfect squares, okay? Remember the beginning of this lesson, we started talking about perfect squares, things we like taking the square root of. That's what we want to do. And not only find any perfect square, but hopefully the largest perfect square. That will make our life easier. So they're helping us out a bit here to start. They're saying 72 is 2 times what? What's half of 72? 36. Okay? So, root 72 is equal to root 36 times 2. Yes? Now, why do I want to do that? Because my rule up above says, well, I can split this up, right? Well, let's show you. We just finished saying that this is equal to that. If I got an entire radical, I can split it up. Okay? If I've got an entire radical, I can split that up into its 2 factors. And why do I want to do that? Because we like doing this. We know what that is. We like taking the square root of perfect squares. The square root of 36 is 6. So this is 6 times root 2. And now I have converted this thing from an entire radical to a mixed radical. I have simplified it. Okay, so here in my calculator, I'm going to prove this. That's a little bit I just skipped right above. Square root of 72 is 8.485, so on and so on. That's not a perfect square, so this is an irrational number, right? Goes on forever. Is that the same as 6 times root 2? Because if it isn't, I did something wrong. It's identical. This is the same thing, okay? It's just we're writing this entire as a mixed. And we're also going to do it with cubed roots. So the question is, what is the largest or highest perfect cube in 108? We're not so good with this. What's 2 times 2 times 2? 8. So the cubed root of 8 is 2. I want to look for these numbers. 3 times 3 is 9 times 3 is 27. So the cubed root of 27 is 3. Okay, what am I doing here? I'm making myself a cubed root list. 4 times 4 is 16 times another 4 is 64. So the cubed root of 64 is 4. Which one of these numbers goes in there? 5 times 5 times 5, 6 times 6 times 6, and they probably won't get much higher than that, okay? They start getting big in a hurry. So try to stick these numbers in your noodle. Try to memorize those, because we're always going to be looking for some of these numbers in there, okay? So now what if you can't see what's in there? You do this. Prime factorize 108. I'm going to take a 2 out, okay? Half of that is 54. Okay, what goes in there? I think I know my times table. That's 9 times 6. All right, okay. I'm looking for a perfect cube. Anyone see one of these numbers in there yet? No? Okay, keep going. That's 3 times 3. That's 3 times 2. Oh. 3 3s. I'm looking for a perfect cube. I'm looking for sets of 3 factors. Remember doing this in grade 8 and grade 9? Well, what's 3 times 3 times 3? That's 27. There's my number. So 108 is 27 times 2 times 2, or 27 times 4. Okay? And my rule says I can split this up into cubed root of 27 times the cubed root of 4. Okay? Cubed root in both cases. Now why do I want to do that again? Why do I want to find the highest perfect cube? Because I know what to do with this. This is 3. And therefore the cubed root of 108 is 3 times the cubed root of 4. And this is a lot nicer than this thing. It's been simplified. The numbers are a lot smaller. Okay? That's your task. That's what we're going to do. A couple more and you're on your own. So, convert these radicals to mixed radicals in simplest form. I'm going to do this 2 ways. First, I'm going to do it the long way. Okay? 320. What the heck? What's the largest perfect square in 320? Well, 4 goes into 32 8 times, so 4 goes into 320 80 times. Oh, look, there's a perfect square. I'm going to split this up into 4 times 80, okay? This is the same as this, right? Right? 4 times 80 is 320, okay. And teacher said, yeah, I want to do that because I know the square root of 4, right? What's the square root of 4? It's 2. So this is 2 root 80. And you're correct. But you've only got part marks here. You have not finished it. This is not simplest form. You keep going until you can't go anymore. There's still a perfect square inside 80. Isn't there? Oh, yeah, okay, right, 80. I can take out... Oh, there's another 4. Yes, he's right. I'm going to take out another 4. I'm going to split that up into... 80 is 4 times 20. Okay, so that's 2 times the square root of 4 times the square root of 20. Right? And I want to do that because I know what this is. That's 2. So I've got 2 times another 2 times root 20, which is, let's go here, 4 root 20. Done now? Nope. Not simplest form. There's still a perfect square in 20. So we got to do this one more time. Okay, let's make sure this is the last time. Are there any more perfect squares than 5? No. So this is going to be the last one. So root 20 is the same as root 4 times 5. When I'm going to split that up, because I know what that is. The square root of 4 is 2. So I got 4 times 2 times root 5. And 4 times 2 is 8 root 5. Okay. Any more perfect squares than 5? No. So I'm done. Now it's simplest form. Okay? So like I said, that's the long way. You want to see the nice way? Let's go back up here. Ask yourself, okay, that's a perfect square. I want to pull it out. Okay, I want to stick it in front of the radical here and make this thing a mixed, but are there any more perfect squares in there? Yes. Keep going. There's another one. There's another one. Okay, there's a perfect square. There's a perfect square. There's a perfect square. I want to pull all of those out and be left with just a number that is not containing any perfect squares. So if 4 is a perfect square, then 4 times 4 is a perfect square, 16. And if 16 is a perfect square, and 4 is a perfect square, I can multiply those together, and I still got a perfect square. So 320, let's just highlight it, is 5 times 64. That's what I want to break it down into. That is the largest perfect square. Okay, so let's do this over here. Whoop. 30. That is the square root of 64 times 5. And my rules say I can split that up into that. And I want to do this because I know what that is. That's 8 root 5. So, which is less work? That or that? Obviously the one on the right. Okay? So, I'm just trying to say, if you can't see the largest perfect square, you can do this, okay? I mean, we all both ended up with the same answer here. It just takes a lot longer and you use a little more pen or pencil. Okay, but just keep going until you can't go anymore. But some kids find it pretty tricky to find the largest perfect square. So I'm just saying, you can still do it this way. You can still get the right answer. Just it's not as efficient, okay? But there's no, there's no extra marks for being the first to do the question. All right, cubed root of 6,000. What's the largest cubed root in 6,000? Which one of those numbers goes in there? Remember me saying something about a bunch of zeros? Do we like doing this? Yes. Yes, that's nice. We like doing that because it's easy. How about this one? What's this? Is there a number multiplied by itself 3 times to give us 1,000? Yes, there is. Okay? So don't forget about that one. There's a few more numbers here, but that one would be coming up pretty soon. Yeah, I want to split this into something I like taking the cube root of. And all I got left is a 6, right? So that's the cubed root of 1,000 times the cubed root of 6. I can split this up into the cubed root of 2 factors. That's 10. Okay, that is 6. And are there any more perfect cubes inside 6? No, that's it. So it's fully simplified. Fifth root of 486. Okay, let's quickly make a fifth root table. Just like cube root, if you think that gets big in a hurry, wait till you see fourth and fifth roots. So 1 times 1 times, don't even bother doing that one. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Okay? So 2 to the 5th power is 32. So the 5th root of 32 is 2. All right, let's look at 3. 3 times 3 is 9. And 3 times 3 is 9. And 9 times 9 is 81. It's 81 times 3. 3, 24. 243. So 3 to the 5th is 2. See, like I said, they get big in a hurry, eh? Huh. You see one of these numbers inside of here? If I take half of that, what do I get? And yeah, I kind of like, you know, I'm going on a little bit of memory here. You're saying, well, I would never do that on my own. But, okay, everything comes with experience, right? So, anyway, this is what I want to split this up into. Okay, why? Because I know the 5th root of 243. Okay, so that is the 5th root of, let's put the 2 first. 243 times 2 is 486. I can split that up into the 5th root of that times the 5th root of that. Why do I want to do this? Because I just figured out that this is 3, right? So I got the 5th root of 2 times 3. So what if you did it like that? Well, you'll just notice in the answer, of course, they always have the number out front, right? Right? Like 2 times x is the same as x times 2. But Math 8 and Math 9 textbooks, I mean, you'll never see it like that. They put the 2 out front because it's a coefficient, and typically it's in front of the variable. Well, same thing. So that's not wrong, but this is how it's going to be written, okay? 3 times the 5th root of 2 is the same as the 5th root of 2 times 3. Okay, last one. Okay, so this says 2 times the cubed root of negative 40. What? It's already a mixed radical. Yes, it is, but it's not in simplest form. We got to keep going. Can I take the cube root of a negative? Yes, I can. And what's my cubed root table? This one's pretty small. Which of those numbers goes inside of 40? Which one is a factor of 40? This guy. Yeah, I want to split up 40. That's 2 times 8 times 5 is 40. But what am I missing? The negative. So do I put it on the 5 or do I put it on the 8? Okay, if I can pull it out, then I'm going to want to pull it out. So I'm going to put it on the 8. So this is the same as that. All right. Okay. And why am I doing that? Because I know what this is. That's negative 2. So I've got 2 times. Be careful with this. Don't do that. Because you know what that looks like. 2 minus 2, 0. No, this is 2 times negative 2. So I've got negative 4. Like I said, I pulled the negative sign out, okay? Which is more simplified. If you leave it in there on the 5, it just, well, again, is it wrong? Is it not wrong? I'm not sure. But if we can pull out the negative, we're going to do it, okay? It's just more simplified. So that's negative 4 times the cubed root of 5, which is, you can always, if you had a calculator, if you were able to use it, you could check. Is that the exact same decimal as this? If not, you did something wrong. Okay, that's it for part 1.